All right, you guys, we're on example number 2 of this whole rhombus thing, and now we are going to look at not only this, but again, here are a couple key words. I want to make sure my thing here. So we're talking about, again, diagonals, and we're also talking about being a rhombus. Okay, we talked about the rules of that already. So now we're going to take where WX, we're talking about WX, which is up here. Okay, we're going to call this one 8x minus 5. Okay, and then we could talk about WZ, which is over here. Let's change colors on this one. Okay, let's go purple this time. So, whoops. Purple, so we got WZ down here. Not doing a very good job on the straight line. Okay, this one is 6x plus 3. Okay, so now what do we know about a rhombus in this case? We know rhombi, if you want to say plural, is that all the sides are congruent. So we know that. So we know that this side is congruent to this side, and this side, and this side. So guess what we can do with 6x plus 3 and 8x minus 5? We can set them equal to each other. So let's go ahead and do that over here. So we're going to go 6x plus 3 equals 8x minus 5. We're going to go ahead and subtract 6x from both sides. Canceling that out. Okay, woo. Made a big old mess here, didn't I? There we go. Okay, let's get back up here. Okay, let's do a different color just for the sake of that. So that gives us now 3 equals 2x minus 5. Okay, we're going to go ahead and add 5 to both sides. Okay, add 5 both sides. Cancels these ones out. Gives me 8 equals 2x. Divide both sides by 2. Gives me 4 equals x. I think that's all we're solving for, is just that right there. Okay, there's your answer on that one. I hope that gives you an idea. Remember, the key thing about this is that all sides of a rhombus are all going to be equal to each other. Even though they mentioned something about diagonals on here, which means that they're trying to throw you off a little bit. Okay, all right. We can talk about any questions later if you need.